We've talked a lot about place value, and here's another application of it with quadratic formulas. You can see that the place value starts with just a single number. And then if we go over to the next column, we're actually going x to the 0 power here, x to the first, x squared, x cubed, x to the fourth, and so on. Every time that we put another place value onto these equations, we're actually making the graph of it potentially hit the x-axis more and more times. They're named actually too, so this is the kind of question, an interpretive type of analyzing question, that you will probably find on your ACT and SAT. The constant tells us that f of x, which is just another way of saying y, our x at our y-axis. So f of x, g of x, h of x, whenever you see that, it means a function. And the f of x means basically substitute y. So y is equal to 3 in this case. It's a 0-degree equation. It has no x term at all. It just has the constant. And the line, if we graphed the line, it would be a line with no slope. In this case, it's at positive 3. So the x-axis itself might be this line, and we would go up 1, 2, 3. So our y, basically, we're saying is 3. In this case, we have a linear equation. When we add the next grouping over, this is x really to the first. We're not showing it, but you could. So we have a first-degree equation. And that equation makes a line, a linear equation, where you can potentially have it cross the x-axis one time in a first-degree equation. The next one, which we're studying now, is the quadratic. Quadratic gives a squared term, so we have a constant that's the x to the 0, x to the first, x squared. And in this case, we have a parabola. It potentially can hit the x-axis 2 times. That's what the green dotted line is supposed to represent, the x-axis. So you can see that here it hits the axis once, here twice, potentially. It doesn't have to. If this parabola was raised or lowered, it might not hit the x-axis at all. But it can hit it up to 2 times. Quadratic. Next is the cubic, and we have our exponent tells us it's the highest degree of this equation. It's a 3rd degree, and it can potentially hit the x-axis 3 times. 1, 2, 3. And so the pattern goes. A quartic is a 4 hit. 1, 2, 3, 4. A quintic has a 5th degree term as the highest degree, and that potentially can hit 1, 2, 3, 4, and 5 times. There are some other things that depend on if the graph shoots the equation higher or lower, where it might not hit the x-axis at all, but potentially it could hit it 5 times. So please copy these into your notes as well. It's great for reference, and now you understand what you're looking for when you actually figure out these equations. That the points of interest would be where they hit the x-axis and how far the graph bumps upward or downward. Those are points of interest that you would be determining if you were going to do some mathematical calculations on this type of equation.